Okay, so I'll be talking today about the Linux client status, which is a very exciting topic for me. I hope you guys also will enjoy it. You know, this is a year that has been kind of crazy in a lot of ways, but it's given us some time to work on some fun, hard patches. And hopefully, guys, we can see next year and work on patches together. Okay, so I think many of you are familiar with me. I'm a member of the Samba team and been working on the kernel client for many years. There's also kind of a team of many people behind this. I think we had over 30 people contribute, 35 people contribute last year from many different companies. So I'm representing the work of many others, not trying to say I did all of this. So I'm going to talk about the general Linux file system status first, because I think a lot of people find that interesting. You know, Samba often runs on Linux, and people actually care about, you know, what's going on in the file system world. And hopefully this fall we can get together and talk about the normal file system arguments at the File System Summit in California. But it is a fascinating group of people who work on file systems. Also going to talk about the goals and then dive into the feature status of the kernel client user space tools. And then I'm going to talk about what we're working on currently and what we'd love some help with. And I'm going to finish up with some sort of common configuration suggestions, because as you might guess, both Samba and the kernel client are over configurable, and that confuses many people. So let's talk about a year ago. You know, right as the pandemic started, we had this octopus thief, right? Remember him, the kleptomaniac octopus? But now we're in a frozen wasteland, hopefully soon to get out of this frozen wasteland. But that's Linus's strange sense of humor as he labels these releases. But we were at 5.7 release candidate last year. Now we're at 5. Well, we're a few days away from the 5.13 release candidate. So for those of you who aren't in the Linux file system world, you may be interested to kind of see what's driving activity. What do some of the arguments on the mailing list have to do with in the Linux file system world? And you know, what's driving the activity? Right now, we have a lot of activity around this whole NetFS and FS cache redesign. How do we do read ahead? How do we map the reads into the file system and leverage these new faster data structures like Xarray? How do we improve containers better? You know, there was a lot of patches for that about 2 months ago. And then, of course, we've had these big discussions with many different people about how would we support Quick inside SMB. And I think you saw that's a focus of some of the test events coming up as well. Another thing that comes up a lot is we have these various attributes for different file systems. How do we expose them to user space? You know, in our case, how would we expose that a file is offline, so the applications don't query information, read from an offline file? So this gets controversial because every file system is different, but that's, you know, been a topic of discussion. And then another topic of discussion has been Verity and encryption on disk. Support for the faster storage, NVMe and RDMA, has always been a topic for the last 3, 4, 5 years. And especially now that we have this new async IO mechanism, IOU ring. And I think that, if I remember correctly, Metz gave a talk about that here already. You know, it's very important for us to better support async IO in the kernel. And then finally, you know, I work in Azure. And, you know, as we go to the cloud, latencies can be quite long. You know, if I'm saving a presentation, it's going to have much longer latencies if I save it in Dublin, Ireland, or in San Antonio. But it's certainly going to be longer latencies than if I save it on a local server. So these are important topics that have been driving some of the discussions. But I don't want to leave out the server. You know, most of the talks here are focused on Samba server. It's fantastic. It's huge, full function. But we now have a kernel server, KSMBD, and you know, as you saw earlier today, Namjay gave a talk on that, and it's been exciting progress. So I hope that you guys get a chance to try out both, but also realize that Samba is unique. There are very few projects of this size that are well written, well looked at server. You know, if you compare it with NFS, it's just what, 100 times bigger. It's kind of crazy to imagine the complexity of Samba and the maturity of Samba compared to other servers. Unfortunately, we didn't get to meet this year in person. And last year we had the opportunity to meet in Redmond, or the year before last, excuse me, we had an opportunity to meet in Redmond, and then it's SNIA events, right? So this kind of opportunity to work together with this fantastic team wasn't possible this year except virtually, but next year I am looking forward to doing this in person. Okay, so back to some real data. So I looked at these numbers yesterday and put them together as an update for those of you who are curious. File system activity is up over the last year for Linux. File systems represent 6.5% of the overall kernel changes, slightly less than others, which means that other parts of the kernel are even up higher. The kernel is enormous, 21.6 million lines of code is even bigger than Samba. And we have a lot of file systems, over 60 of them. But it's interesting because, really could ignore most of them, but maybe 7 you have to pay attention to because they drive 3/4 of all the activity. The most active BTRFS, XFS, ext4, and CIFS, I think you're most aware of. NFS is less active than that, but it's also in the top 10. But it's interesting that even though file systems only have 5% of the source code, less than 1 million lines of code total, they get a lot more attention, a lot more arguments, a lot more contention than the rest of the areas of the kernel. Now, for the module we care about, the Linux kernel client, it's cifsacl is the 4th most active. If we have a good week and put in 3 patches as a hint, if you guys can put in 3 patches this week, we'll be the 3rd most active file system. ext4 snuck ahead of us this year because there was a lot of activity around Verity and some other things that increased their activity unusually more than usual. We would have been number 3 otherwise. It's hard to beat XFS and BTRFS. Their activity is enormous each year. So our code grew 6%, not counting all the user space utils, which are now significantly larger with some of the great work that Relian and Ronnie and others have done. And let's not forget Namjae's work. That kernel server and the dozens of people contributing to that would put it in one of the most active 4 or 5 components as well of the kernel. I mean, there's a lot of work going on in the kernel server. Very exciting. So BTRFS had over 1,000 changes. The VFS layer had 1,400 changes. That was up a lot. What that means to us, what that means to Samba, what that means to the kernel client is there are a lot of changes in things we care about. That mapping layer between user space and the file systems had huge changes. Probably some regressions too, but hopefully mostly improvements. This was an unusual year for that. A lot of changes to the VFS layer. The XFS activity was flat, but still quite high. As you can imagine, these guys get a lot more activity than ext4 or other file systems. Now, ever since the 4.18 kernel, about 3-4 years ago, the CIFS activity has tripled or doubled. It's been the 3rd most active file system over that period. And as you might guess, NFS activity is down a lot over the last 4 years. The NFS server had a good year this year relatively, but even NFS server is down, if you look at a longer 4-year period. But there are other file systems that you may not have heard of. F2FS, that's activity is up this year. It's always very interesting to see what drives some of the other activity, to see what's driving NFS activity, what kind of customer problems are leading to this. But in the big picture, Samba is still more active than all of these guys put together with its 3.5 million lines of source code. So a warning to Samba developers, Linux is changing every year. There are about 850 syscalls, quite a few more than POSIX. And of these 850 syscalls, about 200 of them are file system related. And 4 more came in this year. So, for those of you who want Samba to work well with Linux, you got 4 more syscalls to deal with. So it's a moving target, Linux, and user space developers. The Samba VFS has a lot of work to do to keep up with the kernel changes that are coming every year. We talked about IOU ring last year, and as you can see, it's been taking a lot of attention from Samba developers of those changes. So why do we care about all this? This is repeating an older slide. You've seen this before. we want SMB to be the fastest, most general purpose way to access file data, whether that's in the cloud or whether that's in a $5 device or whether that's, some small embedded router or whether that's some incredibly fast clustered server. It's the general purpose commodity way to access file data, wherever it is. That's what SMB is for. And we want to implement all the reasonable Linux and POSIX features we can. So, apps don't even know they're running on SMB mounts if we can make that happen. In many cases, that's true today, right? They don't know, but there are some things where we have to do extensions to make sure that that the apps don't have to special case SMB. If you look in the man pages, there's lots of cases where the man pages say, if you're running on NFS, it does this, but every other file system, it does that. We don't want that, right? We want it to behave sanely for SMB, just like it would on a local file system. Unfortunately, we also have to deal with the fact that Linux is changing. And so we have to be able to add these features fairly quickly to Samba, much quicker than we are now. And I think, the addition of the kernel server may help with that as well, right? It'll allow us to add features on the server and client at the same time and help Samba have an example to choose from for the larger, more mature Samba implementation on the server. So let's talk about some of the things that, deja vu from a year ago. What did we talk about and some of the amazing progress? I'm just going to skim through this because you've seen it, but it kind of gives you an idea of why this is such an exciting time. So the modefromsid option, this is something that the NFS server on Windows did, and it stores a special SID that's unenforced by the server that has the exact mode bits. And as you can see here, the creating files with all 4096 mode combinations works. It allows the sort of NFS-like model where the client's permissions actually matter and the server has no clue who UID1 is, right? The server may have no UID1 or UID2 or UID3, but the client does, and the client's enforcing the permissions. So that's similar to some NFS use cases, and it's fairly common in Linux when you have servers that don't have any clue who the users are that are defined in the client. Aurelian did some fantastic work last year in 5.5 through 5.8. And there are some cases, especially to Windows, where this can be 5 times faster. But warning, there's a lot of fixes we've been making to multi-channel, and there's still some fixes in progress that Shyam and Aurelian are working on to get multi-channel where we want it to be. Some of the reconnection code paths, for example. But it's a very exciting time with that kind of performance gain. And Ronnie did some great work beginning to add sparse file support, being able to query allocated ranges and to be able to do some of the simpler sparse file operations. That's greatly improved now, but I just wanted to give you some context from where we were a year ago. And the addition of GCM, that work we did, actually at sambaXP 2 years ago, this work began and then was included in the 5.3 kernel, was incredibly helpful for performance. But let's talk about this year. That was a great year last year, but this year, wow. So remember, we have these 3 security models. Remember, we talked about this many times, I think. You basically have like an NFS model where the client has its own UID space, and we really don't know what that is, but the client has to enforce the mode bits. You can see that with IDs from SID and mode from SID. We have this mode that you're probably most used to as Samba developers, where your ACLs have to kind of match the mode bits. So you try to do the best you can to match mode bits to ACLs and vice versa. And the result is that when Windows users access the same share and you're using a multi-user Kerberos mount, you're probably likely to get all the right permissions for everybody evaluated at the server. In those cases, you can mount with no perm. You don't even have to evaluate on the client. You can just let the server do the evaluation only because you're mounting with Kerberos, usually multi-user, multiple clients are accessing it. The ACL emulates the mode bits quite well. So that's a common mode, but it's not as fast as the default. So most workloads today use the default where you set an owner and a group owner and mode bits for files and directories. And that default is what we report to Linux applications. And that default is obviously faster. We don't have to be querying ACLs, and it's easier. But there are cases where client applications want to know the actual mode bits, not just some default. But in most cases, that's what users choose because the server's enforcing permissions. So you don't really need to to have the mode bits on the client, unless there's an application that absolutely requires something other than the default. And in those cases, you have these other two models we talked about. So 3 security models: a client-focused, a kind of multi-user server-focused, and the default model. It's very important to remember those, but they're greatly improved. And I think you can see some of the great work Shyam and others have done to fix modefromsid and cifsacl in these future slides. So what about other security improvements? Well, we did some improvements to Kerberos mounts to make them more usable. And there's also an enhancement to NTLM-SSP. There's a server name validation that is going to be added soon. So we've talked about the 3 different options, but we have now an exciting other thing besides authentication and the different security models. We've added the support for GCM 256 encryption. Some used to nickname this military grade encryption. It's the strongest encryption model out there, GCM 256. By default, Samba would be using GCM 128. And by default, the Linux client since 5.3 would be using GCM 128. GCM 256 is much stronger, obviously, and now supported inside the kernel client. And I just saw patches literally, when I was going to bed at midnight last night from the kernel server to add support for that as well, which is exciting. So some government installations will likely require this, I suspect, going forward. And having GCM 256 in the client and server is exciting. And we'll have even more choices when Quick is available for an encryption option. And of course, don't forget auditing and access control management. We have tools for this in user space. We've added the support for, Amazon guys send in support for setting and getting the auditing information, for example, but also the ability to back up access control better and change ownership through management tools in user space is much better with cifsacl now. So let's dive a little bit into the improved encryption. So AES GCM 256 is the strongest encryption. It's turned off, so we don't require it by default. So if you look at the screenshot here, we have required GCM 256. In this example, I've forced GCM 256, so we only send GCM 256 in this example, and I'm mounting 2 windows here. I set that to yes, and it forces GCM 256, and as you can see, the mount had succeeded. But until this current release, 232, which is going to be the 5.13 kernel, you would also, if you wanted the server to be able to negotiate GCM 256 with you, you'd have to enable GCM 256 from no to yes, because we wouldn't include GCM 256 in our list of crypto algorithms supported unless enable GCM 256 is set to yes. If you set require GCM 256, we only send that as the encryption choice. And in terms of the ordering, the ranking, if you enable it but don't require it, GCM 128 is preferred, then GCM 256, then CCM 128. So it's kind of cool, and I'm very, very happy for that feature. Here's a trace of the mount using GCM 256 where you have required GCM 256 set. You can see we set cipher count to 1 and the cipher ID to GCM 256. Now let's switch gears from security to talking a little bit about performance improvements. So this is amazing. Let's take some simple examples. What if we copy a 10 gig file? Everybody knows about that, right? You can copy a file from, in this case, I copied it from Azure down to a Linux client. Now look at the progress here. I used DD to make it very, very obvious what's going on. With our old defaults, where you wouldn't be using 3.1.1, maybe somebody would specify verse equals 3 or verse 3.0. It was 140 meg per second. Now, just that addition of GCM 256, just the addition of GCM 128, just the addition of GCM 128 got us to 200 meg per second, 40% faster, 41% faster. But what if we did multi-channel? And in this case, I used 2 channels because, with the reconnect bugs we were working through, 2 channels was safer for some of the tests we were doing. But if we go to 2 channels, which is pretty safe, and use this new mount parameter read ahead size, RA size, and set that to, in this case, 4 meg, which is 4 times the read size that was negotiated with the server in this case, we're now at 450 meg per second. So basically all we did was mount with 2 new mount options, and we're 3 times faster than we used to be. That's huge. 3 times faster with just 2 mount options, multi-channel and RA size. So this is kind of an exciting time, 3 times faster. Now, let's talk about another example. Rohith recently, and this is also in the 4.13 kernel, added support for handle leases, deferred close. This is something Windows has done for a while. And in some sense, NFS does something similar with their delegations where it caches across close. Now, I want to give you 2 very simple examples of how this can be incredible. And remember, this is going to Samba localhost, so it would be far bigger gain if you were going to a Windows or Azure server remotely. But I just did an example on the laptop here, right? Localhost. So I created a 2 gig file and read it back. With the handle lease patch, because we're able to cache across close, it's 4 times faster. That scenario. So you can look at the example of what I'm doing. I'm creating a file. So I'm writing a 2 gig file and then reading it right back. And the reading it right back stage is 4 times faster. Another example of the same kind of thing is I take a file that's 4 gig that's already on the server and read it twice. With Rohith's patch, the second time we read it is 3 times faster than the first time because it's cached across that close for a few seconds. So that value of this patch is huge because, even simple benchmarks. There's a benchmark that is ridiculous. It's a useless benchmark, but one of these benchmarks that is commonly used and commonly talked about doesn't clear the cache after it creates the temp file. So on NFS, you can sometimes get 100 times faster because you've created the file, it's cached, they close it, and then the benchmark starts. But the benchmark doesn't actually do anything because it's cached across close. But this kind of pattern where you create something and then read it right back is more common than you might think. We saw significant improvements in some of the build bot tests because even some of the XFS tests do this IO pattern where you write to something, close it, reopen it, or you read from something, close it, and then immediately reread the same thing you just read. So this is a big deal. So what else have we done that's kind of exciting? Well, first of all, before I go on to that, here's the proof. Here's why. So, that example I talked about in the previous slide, not having to do the reads, you can just see it here, the before and after. Reads went from 513 to 0 for that first example of we write a 2 gig file, then read it right back. With his patches, we sent no reads. And we obviously also kind of nicely sent 1 fewer open, as you can see from the trace data here. But that's a very exciting thing. There may be other things we have to do to optimize this. I think we've been discussing, for example, making sure we pass the lease key. There's a couple of examples where we have to do this for the parent lease key for integrating this better with scenarios where we are also caching the parent directory. So this is really big, and 2 huge performance features in 1 short period is great. But we've also had this problem that all workloads are different, and how do we debug this? And dynamic tracing, as you guys probably know, has changed everything in Linux over the last 3 years. And for anybody who wants more information, Brendan Gregg's website and his book on eBPF and Linux dynamic tracing is well worth looking at, and it's online. The dynamic tracing in Linux, this last 3 or 4 years, it's been unbelievably helpful to us. But we just in the SMB, just in the cifs.ko code, have 85 dynamic trace points that you can turn on And we add them, from time to time as we're trying to debug something. But if you have requests for something you want to trace, let's add it, because this allows more granularity and obviously no performance loss when you're not running the trace. So currently we have 85, 10% more than last year, and we continue to add trace points to make it easier to debug customer problems. And the infrastructure here is incredible in Linux for being able to do problem determination now, using some of the very mature user space things with the events that are defined. All the syscalls, for example, you can trace. But for our particular case, we're often tracing where we're getting an SMB error only, or where we're triggering reconnect only, so we can narrow down without flooding our logs these problems, and then correlate that with the Samba logs on the server side or the Azure logs on the server side to try to understand what really is causing the problem and fix it. Okay, another example of a feature we did. We added something called shutdown. Now, if you're curious about what this does, there's a ioctl that XFS had years ago called going down. And ext4 and other local file systems also implemented that when they saw the XFS going down ioctl, and they use the same number. So shutdown is used when you want to unmount quickly and you want to stop the IO that's going to that mount point, so you have a less complicated unmount. And here's an example where we've mounted cifs. We've mounted SMB3 to Samba actually. To Samba localhost, and then we write to a file. Then when we issue the shutdown ioctl, I use the tool go down, which the go down tool calls the shutdown ioctl. Any attempt to open a file, any attempt to rename, delete a file, any attempt to to add xadders or whatever is going to fail with an IO error until you remount or unmount the file system. So here I do a remount, and thanks to our new rewrite of the mount API, using the new mount API, many remount options are possible now. But in any case, the point is we now can do shutdown, and you can see the effect of shutdown. It prevents IO on the share, allowing you to unmount it. In this case, we change the configuration, and that clears the shutdown flag, and we're able to do IO again. It also, and selfishly, the main reason I wanted to do this was to enable about 10 more tests to find more bugs, because XFS tests often rely on that shutdown ioctl. But what are some other examples of things that have been added that are very exciting? We've added, once again in the 5.13 release, we've added support for additional sparse file operations. We've added support for fcollapse, which is commonly used in Linux, and slightly less common, finsert or insert range. And there's, I gave a simple example here. So I created a file, as you can see, that's 300 megabytes. I look at how much disk space it takes up, du-h, the file it takes up 301 megabytes. Then I do fcollapse to remove 10 megabytes from the beginning of that. So basically what this is doing is chopping the first 10 meg out of the file and pushing it down. And then if you look at the disk space used for this, it's now 10 meg less, right? So fcollapse worked. If you tried this earlier, on earlier kernels, you'd get operation not supported, as you can see from the bottom of this slide. But the reason this is important is that there are many workloads that rely on sparse files, that rely on being able to chop a section out of a file or expand a file by putting a section in the middle of it. And this collapse and insert range are now possible over SMB. And as you might guess, we're one of the few network cluster file systems that does support these sparse file ops, which is really good. Also, just a note that things that matter to us, right? We've been debating how to get quick support in SMB3 on Linux over quick. Well, there's been progress with the Wireshark developers. They can now, so this is a Windows trace, so we're looking at Windows using quick. But as you can see, SMB3 can now display SMB3 over the quick protocol, which is going to make our life easier on Samba and on the Linux kernel client in getting quick support working. So let's dive into a little bit more detail. And I think, this detailed list is kind of exciting. We talked before about some of the things that really mattered previously. One of the things I loved about, last year, something as simple as cutting network requests using better compounding, 10% improvement through this one little change. And that was a really cool thing, just reducing the number of round trips when you open a file. We talked about the GCM improvements. There was some fantastic work by Long Lee on RDMA. RDMA on the Linux client is 85 or 90% as fast as it is on Windows, which is amazing. smbdirect is cool. Paolo did that great work on booting. You can boot a diskless client now over SMB from Linux. And there was also this pass-through ioctl. So a lot of these tools can now basically call setinfo, queryinfo, fsctl from user space without having to write a client themselves. And a small little 10-line user space program can do a lot of fun, important things. A lot of new mount parameters added. We added support for the BSD whole file lock, the multi-channel support we talked about. We added another simple performance optimization, being able to query attributes on close. That also allowed us to cache metadata another second longer. So after we close the file, we have the metadata for another second. That really helps performance in some workloads. And we also improved reader, queryder. Going forward, being able to save off more of the metadata for backup and restore. Boris's work at Amazon was helpful here. This reader performance optimization, cutting the number of round trips when you're querying a directory contents. We added the ioctl for change notify. So if you want to wait on notification, about a directory changing or file changing, you can do that now from user space. There is a problem with the Linux VFS, as you probably know. There is a notify API in the Linux VFS, but it's only for local file systems. It doesn't have a hook for a network file system to be called for it. So we need to tie in our ioctl to that somehow. There's a little bit of VFS changes needed in Linux to support that. But since SMB is really the only network file system that does notify, it hasn't been a priority for anybody except us. We had a big improvement for sign connections in 5.7. We had RDMA improvements. We can now support swap files over SMB. And then we talked about the improvements in multi-channel and IDs from SID. We also had an interesting customer bug where they had a buggy app that deleted files incorrectly. It's interesting. So easy. We added another mount option. Kind of reminds me of Samba. We end up with hundreds and hundreds of config options. But in this case, you can write to the share, you just can't delete a file. That was sort of like a variant of the read-only thing that was needed for a buggy customer app. So going forward, this ID from SID mount option has been really helpful, but some of the servers were kind of quirky about how they supported it on create. So we had to make some changes to that to work around what the server requires for that. So, IDs from SID, that's why IDs from SID, although it was introduced earlier, the ability to do this sort of NFS style security where the ownership information is stored on the server, even if the server doesn't know what it means, the client can enforce it. Also, WSL, the Windows subsystem for Linux, creates special files and stores them as reparse points. If you had a Windows server, or if you were backing up from Windows server to a Samba server, you'd see these reparse, well, maybe not to Samba, but Windows to NetApp, let's say, you'd see these as a reparse point. Well, how do we recognize them on Linux? We had to be able to recognize that FIFOs and symlinks and things like that were created on Windows are actually symlinks. So adding the special file support was done in the 5.10 kernel. And also, we haven't talked about it a lot in the presentation so far, but the POSIX extensions basically are complete on the client side, and there were some fixes here in 5.10 to return the owner information properly. Now in 5.11, we had a huge change set, and it caused a few regressions, but they've been fixed now. But this huge change set was to rewrite from the 30-year-old, 20-year-old mount API to the mount API that was added a couple years ago. The new mount API is much better about error handling. It's much better about doing things like remount. And Linux, the cifs client moved to using the new mount API. It's a large set of changes. And there was also another exciting set of changes to allow support for the witness protocol. So for example, when a server moves, the client now gets notification of that. If the address changed of the server, we get notification about that on the client. So that's kind of exciting. And hopefully in the future, we can extend the use of witness protocol for other server events to get the dynamic notifications. In the 5.12 kernel, we added some exciting performance optimizations. NFS has this way of distinguishing between how long you cache file metadata and directory metadata. And in many cases in Linux, since it's a Linux VFS, forget SMB, is extremely chatty. It has to revalidate every single entry in a path. So, having an AC durmax of 60 seconds like NFS makes more sense for some workloads than our default, which is 1 second. Sure, there are cases where, the 60-second timeout is bad for a directory because, the directory could be renamed or deleted and cause unexpected errors. But in most cases, NFS guys just decided that it was a better trade-off to not have to send as many revalidate requests to the server. So they allowed you to distinguish between AC durmax and AC regmax. In other words, how long you cache files and directories. If you set AC timeout, which is what we supported before, AC timeout sets both AC regmax and AC durmax to the same value. We default to a very strict timeout of 1 second. But if you have a workload where directory names aren't changing much, you might want to set AC durmax quite large, and that'll reduce significantly the number of queries that have to be sent over the network to Samba. And imagine why this is useful. It's incredibly useful because not only does it send fewer requests, but when you have a deep directory tree, the amount of work the server has to do is a lot less, because in some of these workloads with deep directory trees, and you see this with Git sometimes, right? The metadata operations overwhelm the server compared to the reads and writes of data. So these mount options can be helpful. Also, we have a problem because there are some Red Hat versions that are still popular, CentOS Red Hat versions that don't support SMB3 by default, and they're running older kernels. And so, what if you have to mount with SMB3, which I think everybody should. We shouldn't ever be using SMB1, right? And we had the problem of, okay, well, if you're trying to give people configuration advice, what could you tell them? If you left off the dialect, it would work fine for kernels past a certain point, but older kernels would end up negotiating SMB1, which we never want to do. But if you set it to versiql 3.0, then you'll miss all the performance changes of 3.1.1. So the options people often had were putting in versiql 3.1.1, which would fail to some servers that don't support SMB 3.1.1, or not getting the performance advantages they want. So we changed versiql 3, which means 3 or later, to mean not just 3 and 3.02, but also 3, 3.02, or 3.1.1. What that means is that if you're worried about some of your customers using an old Red Hat or something, or an old CentOS that only supports SMB1, at least with versiql 3 now, you'll get the fastest support if it's available, but you'll never get SMB1. We also did some important fixes for cifsacl and for ID mapped mounting. So these ID mapped mount, these namespace mappings, were generally added across the VFS in 5.12 for various container workloads. And as a result, they also changed CIFS and added CIFS support for this. So you'll see, if you're running 5.12 or later, improved container support for Linux. In the 5.13 release we talked about, we have the support for fcollapse and finsert. We have the huge performance boost for read ahead with this RA size optional mount parm. Our recommendation, especially if you're using multi-channel, is set that to at least 4 times what R size is. Also, the support for deferred close has been helpful. Now, we've added the support for GCM256 and also added the ability to debug GCM256 because they have longer decryption keys. We need to make sure that that works to Wireshark as well, that Wireshark can debug GCM256. We've also added the ability to, as root, to dump the decryption keys for other multi-user mounts on the same location, so we can to the same socket, so we can be able to decrypt the various multi-user sessions in Wireshark. We added the shutdown octal we talked about, and also added various Aurelian had some nice patches for handling errors better. So cifsutils improved a lot. We can talk about that at a later time, but here's some exciting information about the cifsutils changes. And going forward in the future, because I know we're running out of time here, what should we expect? I think in the short term, we have a couple people working on multi-channel reconnect improvements and multi-channel failover when you're short of credits or things like that, handling that a little bit better. We've had some great discussions about SMB3 over Quick. We're leaning toward using a user space driver. For example, MS Quick is fairly well tested, runs on Linux, maybe using that in the short term, having an upcall for Quick. As we solidify the SMB3 support, then move to porting one of the smaller user space quick drivers that's more kernel friendly into kernel, into CIFS, make sure it works, and then gradually move that into the net tree. We're looking at additional sparse file improvements. There's some great things relating to improving SLE rename, for example, for some of these POSIX workloads. But I'm particularly excited about just small things like improving the use of compounding so we have fewer round trips to the server when we retrieve an ACL. Or some of these things we're going to talk about in the talk that follows this about improvements to the POSIX extensions and POSIX emulations. Not necessarily new dialects, but ways of adding slightly better support. And also, as we echoing what we saw in the talk just before this with Alexander about FIPS mode, we really need to support additional authentication options for peer-to-peer authentication, and that could be PKU2U, for example. Because that's going to be required going forward. You know, there are cases where we just can't use NTLM v2. And obviously Kerberos isn't very helpful if you're not domain joined. There's various minor miscellaneous Linux features that we'll talk about in the next talk for you guys who are curious. We can discuss that later. Some general configuration advice here. There are lots of parameters. Focus on these. Things like no strict sync, RA size, AC dir max, AC reg max, multi-channel, sec equals, those kind of focus on those. Don't focus on the other 100. There are way too many config options we have. And thank you to Paolo, Ronnie, and Aurelian for the great work on the build bot. We keep adding tests. The regression tests keep getting better. They're catching regressions before we send them upstream. It's been fantastic. We keep adding test after test. It's really helping quality, and it's made it a very exciting time and the best releases ever. And thank you guys for your time.